Hello everyone, welcome. The previous video in this series has been database sharding. Now there were two main problems with the database sharding. Okay, what were those problems? First is that whenever server goes down, not only the keys that were mapped to this particular server are going to be remapped, but also the keys that were present on other servers, the servers which are still live, are also going to be remapped. This is first problem. What is another problem? It may happen that hotspot keys or celebrity keys are mapped to single server, right? Now in this particular case, the load on this server is going to be a lot more in comparison to other two servers. Okay, so these are two problems related to database sharding. Now how do we solve these problems? These problems are solved using technique called as consistent hashing. We'll see the consistent hashing technique now. To understand consistent hashing, consider a hash function h. Okay, what does h do? Whenever hash function h is given a key k, it gives some value. Okay, it gives some particular value. Now this value is going to be in range of 0 to n. Okay, so the value could be anything between v0 to vn. That is, you give any key to this hash function, the values are going to be between 0 to n. So as you go on giving values, the value would be v0, v2, v1, v3, v5, v4. It goes till vn and again it wraps back to v0, v1, v2 like that. Okay? So if you see on this particular line, the values are going to be from v0, v1 to vn. Okay, now because these values wrap around or these values repeat themselves, we can also consider it as a ring. So value starts from v0, it goes v1, v2, v3 and so on, and later the last value would be vn, after which it will wrap around. It will again start giving v0, v1, v2, v3. Okay, so this is our hash function. Now how do you map a server to onto this ring? So what will happen? You can use anything like IP of the server or name of the server. You give any of these two as key to the hash function. Let's say we give IP. So we have server S0 and its IP is IP0. Okay? When you give IP0 to the hash function, it will give some value. Okay? So let's say its value is VS0. So let's consider VS0 is present on this position on our hash string. Now let's say our system has got 3 servers. Okay? So similarly, using IPs, we will get values for S1 and we'll get value for S2. Okay? So let's say VS1 is here and VS2 is here. Okay? Now how do these keys get mapped to server? So let's say you have 6 keys and the output of hash function for all these keys is, let's say, vk1, vk2, vk3. Okay, so these are the keys. Now let's assume these key positions are like this. So vk1 gets mapped here, vk2 gets mapped here, vk3 gets. So these are how the keys are going to be mapped onto the ring using our hash function. So there are multiple slots and based on the slots they get mapped onto the ring in this way. Okay? Now what does consistent hashing say? Consistent hashing says that from a particular key position. So wherever a key has been mapped onto the hash ring, from that position you go in clockwise direction, and whichever server you encounter first, that is going to be your server. So we have three servers: S0, S1 and S2. Now if we go in clockwise direction, 1 and 3, key 1 and key 3 are mapped to S1. So K1 and K3 are mapped to S1. Key 2 and key 6 are mapped to S2. Key K2 and K6 mapped to S2. And key 4 and key 5 are mapped to S0. K4 and K5 are mapped to S0. Okay? This is how the keys are assigned to or mapped to the servers. Okay? Now, what was the first problem that we had encountered in the database sharding problem? The first problem was that whenever a server goes down, almost all the keys were getting remapped or redistributed. Does this solve this problem? Let's see. Now let's say that server S1 has gone down. So when server S1 has gone down, okay, let's use some other color. This server has gone down. Okay, this server does not exist. So what will happen? According to the rule, key K1 and K3, they will go in clockwise direction, and now the first server they will encounter is server S2. Okay, so K1 and K3 are going to be remapped to server number 2. Now you see, in the previous method 4 out of 6 keys were getting remapped, but here only 2 keys have got remapped. Okay, this is how the problem of remapping is being solved. So what is consistent hashing trying to do here? So in our example we had k is equals to 6, we had 6 keys, and initially we had n is equals to 3. Okay, now when n was changed to 2, we assumed that one server was down and was changed to 2, then we saw that only 2 keys were remapped. Right? So what does consistent hashing try to do? Whenever the hash ring size is changed, it tries to keep the number of remappings less than k by n. In our example, k is 6 and n is 3, and this is true in our case. So 6 by 2. After the size of hash ring is changed, n is equals to 2, right? So 6 by 2 gives us 3, and yes, the number of remappings that happened were 2. So yeah, this stands true in our case. Number of remappings were less than k by n. Okay, this is what consistent hashing tries to do. Okay, this is basic consistent hashing. Now there are two problems with these approaches. The first problem is that we need to make sure that partition size is equal. Okay, each partition should be of equal size, but is it of equal size? So let's say, let's randomly redistribute the keys again. Let's say k1, k2, k3. Currently each server's partition size is equal, right? But if you say, or if you assume that this particular server goes down, then the partition size of this server would be 1, 2, 3, 4. but partition size of this server is going to be only 2, right? So one server is getting double partition size in comparison to another server. This is one problem. Another problem is, let's say everyone has got equal partition size. Okay, so what is meant by equal partition size? The number of slots here is equal to number of slots here is equal to number of slots here. Okay, now even if they get equal partition size, it may happen that the keys are going to map into one particular slot more number of times than another slots. So in case, um, consider the 6 keys example once again. It may happen that 1, 2, 3, 4. 4 keys may get mapped here, one key will get mapped here, and one key will get mapped here, right? So it could be a case. So there are two problems with this basic consistent hashing approach. How to ensure partition equal partition size, how to ensure this, and next is how to ensure uniform key distribution on hash ring. Okay, these two are the problems. Now how do we solve this problem in consistent hashing? We'll introduce something called as virtual node. Okay, let's understand this. Now consider a case where we have only two servers, S0 and S1. Okay, so what we do, we will assign virtual nodes along the ring for both these servers. Okay, so all the nodes in yellow color are virtual nodes corresponding to S0, and all the nodes in red color are virtual nodes corresponding to S1. Okay, now for both these servers we'll assign virtual nodes all along the ring. There is no partition. On complete ring we'll assign virtual nodes for each server. Now what happens by this? See, so let's say this is virtual node 01, this is virtual node 02, this is virtual node 03, and for server 1 virtual node 11, virtual node 12, and we have virtual node 13. Okay, now how does key distribution takes place? So let's say we have keys mapped here, then some keys mapped here, some keys mapped here, some keys mapped here, and some keys mapped here. So now how will key mappings happen in this case? So all the keys that are mapped between this region or between V01 to V11 are mapped to V11. All the keys between V11 and V02 will be mapped to V02. It is same rule. You go in clockwise direction, and whichever server you or whichever virtual node you find next, the key would be mapped to that particular virtual node. Okay, so like this it would be mapped. Okay, this particular region belongs to V11, this region belongs to V02, this region belongs to V12, this region will belong to V03, and so on. Okay, so all the keys that are mapped to V01, V02, and V03 are actually the keys that are mapped to server S0. And all the keys mapped to V11, V12, and v13 are mapped to server S1. Now what is the advantage of doing this? No particular server will get keys from one particular region only. Without virtual nodes, a particular server was getting key from single region only, but here there are virtual nodes distributed all along the ring. Okay, so a server will get keys from complete ring, not one particular region. So this is the advantage of doing that. Now as you go on increasing the number of virtual nodes, the uniformity of distribution goes up. So this variation of consistent hashing helps us solve both the problems. It will minimize the distribution remapping of keys when the ring size is changed, and it will also help mitigate the hotspot key problem. Okay, it will try to distribute the keys evenly with all servers. I hope you would have understood this. Thank you.